problem. Carol's flying a kite on level ground. The string forms an angle of 50 with the ground. Two friends standing some distance from Carol see the kite at angles of elevation of 66 and 35. Angle of elevation is when you're looking up, right? So angle of elevation, right? And again, this was when you're looking up at something. So you're standing here and you're looking up. So this is the angle of elevation, right? Looking up at something. So it's like your eyes, you're looking up at something. So angle of elevation, 66 and 35 respectively. All three of them are standing on the same side, and there's 11-meter distance is between the closest friend to the kite and Carol. So I'll have to fix that in a minute. That's going to be more specific. How high is the kite above the ground, and how long is the string? Alrighty, so let's draw the diagram. I'm going to use a ruler. You don't have to. I'm just doing it because then I keep my notes a bit neater for you. So I'm going to try to do a diagram here. Carol is flying a kite on level ground. The string forms an angle of 50. So I'm just going to put this in the middle somewhere to get a 50. So 50-ish, something like this. So 50 makes an angle of 50 with the ground. Two friends are standing some distance from Carol to see the kite at angles of elevation. They're going to look up at this kite. So we have a kite. Right? Oh, there's the kite. Oh, it's so pretty. It's got a little tail. Okay, so there's our kite. Okay, so she's flying a kite up there. They're looking up at the kite. All three of them are standing on the same side of the kite. So, because this would be a different diagram if one friend was standing over here, it would make it a wider triangle, or are they all standing here, or anything like that. So they specifically said, yep.
How do you know that Carol in the middle or not?
Oh, she could be here. Just because I was reading ahead and it's 35 and 66. So otherwise I'd have to extend it. So if I did this, so Carol was 50. Her two friends are looking up at the same kite. One of them has a distance of 66, angle of 66. So is that friend closer to the kite or further away? So if you're looking up at the kite and your angle is 66, which is bigger than 50, are you standing closer? Yes, so it's going to be this angle. So 66 goes here, right? Closer angle. And the 35 is going to have to go behind. So I'm going to extend it behind, so 35, so smaller. Right? So I just put it in the middle because I looked ahead and I saw 66 and 35. If both of them were bigger, she'd be at the end in here. So I just make the floor bigger, right? So make the ground long enough so you can have the friend standing somewhere. So the friend who's looking at the same kite at 66, I'm going to drop it here and make this one 66. Does that make sense? So it's looking up at 66. And the other friend is further away because it's 35. So that means that the angle of elevation must be over here. There you go. Right, and depends on the description. I can do the same question. I can have the friends all be standing closer, everything like that. So it just depends. Listen to the words. All three are standing on the same side. There's 11 meters between the closest friend to the kite. So that would be 66. 66 is closer to the kite, yes? Agreed? Okay. 66 closer. Between the friend who's closer and Carol. So this distance here is 11. All right. What are they asking for? How high is the kite from the ground? How high is the kite from the ground? So we're going to do this. Drop it straight down. When I ask you how high, that means it's 90 degrees. Then we're allowed to use SOHCAHTOA. So if we can use SOHCAHTOA, we are allowed to. So 90 degrees means we're allowed to use SOHCAHTOA again. Okay, only with 90 degrees. So I want to find the height. So if I can use SOHCAHTOA, so if this is 90 degrees, can use SOHCAHTOA. Okay, that's my brain going, ooh, I'm allowed to. If I can, I want to find the height. So I want to find that height. How high is the kite? Oh, that's my first question. Okay, so let's find the height. Yes?
How did you get
11? 11? They said all three of them are standing on the same side of the kite, so I drew them all here. The 11-meter distance is between Carol, who's here, this is Carol, right? So that's Carol. And between the closest friend to the kite. So the person has a higher elevation. If you stand closer to something, your neck cranes higher, right? So you're looking higher at the kite. This person's closer to the kite, and it goes 11-meter distance between the closest friend to the kite, which is this here, 66, and Carol. So between the friend and Carol is 11, right? So between this and this one. Good? Okay. All right? You got the okay, now H. How can I find H if I have this information, all of these angles, way too many angles? Can I find H? In order to find H, don't I need one of these sides for SOHCAHTOA? Can't really do anything, right? So can't do, nope, can't reach there. Okay, so let me go on to B. How long is the string? What if I find B first? Right, so there's no rule you have to answer it A, B. So let me try B first. So how long is the string?
You can find the angle like by the time during the time.
I can find this angle, yeah.
Yeah, and that angle. And then you have the 11 angle.
11 angle, yep. I can also find this angle. Supplementary. I can find all the angles. Oh, angles we've got plenty of, right? So angles, let's start filling in. So if you're not sure, start filling in stuff. Go, you know what? I can find all the angles. I'm just going to find it and see if that brings me to the sine law or something else. So the goal is find some angles. So let me fill in this one. What's this one? 114? Okay. We can find this one. We know that one as well. So, oh, I know this little one. This little one would be 180 minus, I'm going to write that down. So 180 minus 50 minus 114, right here. And that would be how much? 16? 16. Here you go. So I got that. And I have the 11. The reason why I'm focusing on that triangle is because, look, I have the 11. So the 11 is a useful piece of information. So I'm going to go to this triangle. Is there any way I can find how long the string is? And then I'll come back and answer that later. This, I'm going to call it, should I call it X? I'll call it X. And this is the length of the string. So that's from Carol up to the kite. Okay, so that's X. So yes, so now I have, can I do SOHCAHTOA? I can. Look, I have this scenario here. So this is the SOHCAHTOA scenario where I have angle and its opposite side. So let's go ahead and do SOHCAHTOA. What a coincidence, we're in sine law. Sorry, not SOHCAHTOA, sine law. Sine law, I keep saying sine. Go ahead and use sine law, and the coincidence is we are in the sine law section. So we're going to do sine law, because we have this. So x over sine of 114 equals 11 over sine of 16. I just need to see this. Then you can bring this one up and just calculate that, and x is approximately... Someone tell me what they got. Oh, I don't know if I have it. 36.5. 36.5? Okay. There you go. Yes? Agreed. Okay. So therefore, the string is 36.5 meters. Make sure you put units, and we're done. So even if you answer the second part first, that's okay. Okay. What else can I answer here? Do I have anything else that I could answer? So I'm trying to get to the H here. Is there any way I can get to the H if I go and make the triangle bigger? So if I take it all the way to the 50. Yes. I have angle.
Like if you look at
the big triangle?
You have like the triangle with X and H.
Yep.
You have 50 degrees.
Yep.
You have X.
Yep.
And you can find the big angle by 180 minus 50 minus 9.
But wait, all I need is the 50. Don't I just need the 50 and the X, which I have from over here? Yeah, 36.5. So look, that goes to H. The 50 is here. I have 36.5. Now I can use SOHCAHTOA. Yeah, you can find it that way as well, but try to look for an easy way too, right? So go stretch it out. I sometimes redraw it and go, wait, if I'm looking at this, ignore the middle line and redraw it and go, oh, that's SOHCAHTOA right there. So then to find h, it would be sine of 50 equals h over 36.5, and we're good. So for the second part here,
Wouldn't it be?
or the first part. Sorry, which one?
Oh, no.
So, yeah, h is, yeah. Opposite over hypotenuse, yeah. So h over 36.5. Bring this guy up here. You don't have to show me that, but it'll be 36.5 sine of 50 equals h. So show me this line and your answer. And that I'm getting, can someone check for me? 28 rounds, 28.0. There you go. So therefore, the kite is 28.0 meters high. So draw the diagram. Sometimes there's extra information, sometimes there's not enough, but you have to find something else first. All right.